Volume of cube is nothing but a power 3. So that is what we are doing. We will be describing a functional relation between two quantities or single quantity, which one quantity varies as a power of other. For example, in this volume, we have only single quantity, whereas you will be when you take cuboid or anything, we will be having two or three quantities where it varies according to the power it has. So that is what power law degree distribution speaks all about. So let me write the definition. So it describes a functional relationship between two quantities where one quantity varies as a power of the other. That is what it all speak about. It is a functional relationship between two quantities, that is either it may be length or breadth. For example, if we think about real world situation, if you take the degree of a, for example, let me take notes. Here, what's the degree of a? Degree of a is 3. So what is the power of 3? 3 can merge with another 3 nodes, and 3 nodes can be merged with another 3 or 4 nodes. That is what you speak about. So when a node is combined with another node, it always increases its network. That is what power law degree distribution speaks about. So I think you have cleared your concept. So let us move to the second properties of real world network, that is cluster coefficient. So cluster coefficient is nothing but it is a measure of degree. We'll be dealing mostly with the degrees to which the nodes the graph tend to cluster together. So we'll be having two or three graphs, right? So from two or three graphs we'll be finding the measure of the degree, so that the graph tends to form a cluster together. How does the cluster forms? Cluster forms based upon the interest or the links between them. So why we need clustering? Why we need cluster coefficient? So by to increase the strength of the network, we need cluster coefficients. And what is the most use of clustering? Most use of clustering, that it has bandwidth, it will provide security, it has effective information passing. So all the advantages are mostly seen in cluster coefficients. So that's why this is one of the properties of real world network. So let me write the definition. So cluster coefficient. So cluster coefficient is a measure of the degree to which nodes in a graph tend to cluster together. So tend to cluster to, it is a measure of degree. So we will be mainly dealing with the degree. We will be solving two problems on this cluster coefficient, or if you want I will be doing more problems. So this is what the difference of cluster coefficient means. We'll be measuring the degree of to which node in the graph tends to cluster together. We'll be finding the node. For example, if we remove that cluster node, what will happen? The two graphs will split into two graphs. So that is what the cluster coefficient speaks about. For example, if there is a customer, okay, and if you want to send any information, if you want to send a packet using, so for example, if he is a person, and if you want to if you need to courier to a person B, what we will be doing, you will be going into a post office to send to the customer B. But what will happen if the customer B is if the post office is not present, how A can send to the B? So there is no relevant path from A to reach B. So that is what cluster coefficient mainly deals with. So why we need cluster coefficient? We need cluster coefficient to increase the strength of the network for effective information passing. So we'll be only, these are the main two advantages of main advantages of cluster coefficient. We can increase the bandwidth also. Bandwidth, it provides high security. So based on upon your marks of the answer, you can include as many points you can. So let us try to formulate the cluster coefficients. The formula for cluster coefficient is, so cluster coefficient of vertex is equal to 2 n vertex by kv of kv minus 1. So we will be defined where v is a node or slash vertex, kv is the node degree. What is NV? NV is nothing but it is a link between the vertices or the nodes. The number of links between neighbors of B. So this is a formula for cluster coefficient, that is 2 NV by kV of kV minus 1, that is 2 into number of links between the each vertices by the degree of the each vertex. So why we need to take kV of kV minus 1? So because we will be dealing with the probability distributions in social networking. So the probability should be 0 less than or equal to x less than or equal to 1. It should be between the range of these two values. So that's why we will be taking denominator as kV of kV minus 1. That is the node degree of node degree minus 1. Because we have to get into the range of 0 to 1 itself. So let us take one example to do this. So let me take a graph. So this is one of the graph A. Let me take A, B, C, D, E, F, G and H. So this is the graph they have given. So we need to find the cluster coefficient for this graph. So finding So in case in exam, if they don't give for which node we need to find the cluster coefficient, check whether see the graph and find that which is the most relevant node for which the graph may split. For example, let's consider this graph. So what is the most relevant graph that it can split the graph into two parts? So it is D. So if we remove D, what will happen? There is no path between F and B, as well as G, as well as HB and G, HF. That is what it actually makes a difference of finding a node which will make a clusters. So let us find the cluster coefficients for node D. So cluster coefficient for node D. So let us try to formulate cluster coefficient of D is equal to, that is what the formula, 2n D by KD of KD minus 1. So what is 2 of what is ND? ND is nothing but the number of links between the vertices between the neighbors of V. So before that we will be writing the degrees. Let's find out the degree. What is KD? KD is nothing but the node degree. So what is the node here? D is the node. What is this degrees? 1, 2, 3, 4. 4 is the degree. So 4 of 4 minus 1, 3. So we got all the values. Before doing that, just try to make the notations. So V here is D and KV node degree is 4. And what is NV? So NVV. So that is number of links between vertices is equal to, just find the number of set of nodes which is linked to. So D is linked to C, D is linked to B, and D is linked to F, and D is linked to H. Now find whether the nodes have a link between them or not. So CB has a link or not. So CB has a link, so make it 1. So now BF has a link, but this should not, BF doesn't have a link properly, so we'll be not taking that. So you should not find any intermediate nodes between them. So fh has a link? No, it doesn't have a link. This doesn't have a link straight through. So only the number of nodes. So every node for D, the every neighbors of a D has to have direct path, so that it will be counted for ND as an ND, because it is the number of links between the neighbor of vertices V. That is the neighbor of vertices G. So CNB is the only pair there where we have directed path to the CB. So here ND is equal to 1. So what will be the solution? 2 by 12, that is 1 by 6. So CC of D is nothing but 1 by 6. This is the way where we need to find the cluster coefficients of node D. You can find the cluster coefficients of node C also. So if you take node C, there is no possibility. So let me take another example, so that you will be make sure that you will be easily understand the concept clearly. So let me take another example. So this is a one. So this is one of the graph that is known as star graph. So let us find the cluster coefficients of node D. Cluster coefficients for node A. So what will the cluster coefficients of node A? By seeing the graph, we can say the cluster coefficient will be 0, because there is no links between the neighbors of A. So let us try to formulate it. So CC A is equal to 2 NA by KA of KA minus 1. So 2 NA we don't know. Let we see later. What is KA? KA is nothing but the degree of A. What is the degree of A? 1, 2, 3, 4, 5. Degree of A is 5 by, so 5 minus 4, 5 minus 1, 4, that is. So now we have to find the links between the neighbors of the A. Is there any links between the neighbors of A? BC doesn't have a link. CD doesn't have a link. DE doesn't have a link. EF doesn't have a straight directed path. So the degree of the number of links between the neighbors of vertices A are 0. So the resultant will be 0. So CC of A is equal to 0. So this is one example where the probability is 0. That is, if any star graph is given, then the cluster coefficients of node A will be 0. Let us do another example. So let me take another example. A. So this is another graph. This is called cyclic graph. Like you can pronounce this as anywhere. Like graph. So let us find the cluster coefficient of A. Let us make C, D, E, and F. So let us find the cluster coefficient for this graph. So cluster coefficient for node A, CC of node A is given as, so CC of A is equal to, what is 2NV by, 2NA, it's NA by KA of KA minus 1. So let us write the NA later. What is K? K is nothing but the degree of A. What is the degree of A? 1, 2, 3, 4, 5. So degree is 5 of, what is KA minus 1? It is nothing but 4. So now let us find the links between the neighbors of the vertices, neighbors of the vertex A. So let us find the link. So what are the set of NA? So A is linked with B, C, D, E, and F. So let us find the links between them. BC has a direct link. Yes, BC has a direct link. BD has a direct link. From B, it has a direct link. C. From B, it has a direct link. B to E. So B to E also has a direct link. B to F. So B to F. I think we have missed it. So B to F, here you can see that B to F is present. From C to D, so from B we got 5. From C to B, okay. C to D, Okay. So if you in case you if you don't need to find, so this is how we need to check for each and every node. For example, now we can calculate directly, that is every vertex has is their own link. So for from A it is 1 2 3 4 5. So direct links are 5, and we have to check the circle links. Circle link is 1 2 3 4 and 5. How many circular links are there? 5. So total links 10. So 10 links are present 10 links are present between the vertices, between the neighbors of vertices A. So total will be getting 20 by 20 is equal to 1. So CC of A is 1. So these two graphs are the properties of cluster coefficient, that cluster coefficient is 0 for a star graph and cluster coefficient is 1 for a clique. So you can write the ranges as well. So range CC of A is equal to 0 when it is a star graph, and CC of A is equal to 1 where it is a clique graph. So that's all about cluster coefficient. I think hope you understand what is cluster coefficient and what is it used for. So we need to find, so let us recap what is cluster coefficient. Cluster coefficient is cluster coefficient is nothing but we need to we need to find the measure of a degree to which node the graph tends to be clustered together. So now we have to, so we feel that D is the main important node in this graph, so we have taken D as a cluster coefficient node, and we have formulated it using our formula given. So ND is nothing but the number of links between the neighbors of D, and what is KJ? KJ is nothing but the degree. So we have tried to formulate it. CG of D is 1 by 6. 1 by 6. So for a star graph is always it. So star graph it is always 0, and for a clique it is always 1. So this is what this is all about cluster coefficient. Now let us move to the third properties of real world network, that is average path length. So what is average path length? Average path length is a concept in network technology that is defined as the average number of steps. We need to find the average number of steps along with the shortest paths of all possible pairs of network node. Try to solve the example. You will be getting it easier. It is very simple problem. So it is nothing but it is a measure of measure of efficiency of information or mass transport of a network. So what we will be doing, if you need to find the shortest path between any two nodes, that is what it always speaks about. For example, if a person want to go to a shop, uh, here it is his house, and here to here it is 10 km 10 meters, and for the shop to reach here it is 20 meters. It is another shop. So this is another shop. So a person will be choosing which shop. He'll definitely go to the 10-meter distance shop, or based on the quality or the information he may choose 20-meter shop also. That is what average path deals with. We can easily relate to the shortest path distance also. That is what. So let me give the description of the average path length. Average path is nothing but we have already told that it is a network topology that is defined as the average number of steps. So it is a network topology that is defined as the average number of steps along the, so this is L, along the shortest paths for all possible paths of a network nodes, for all possible paths of network nodes. So this is, we will be defining the average number of steps which are required for two shortest paths. So we need to find the average number of steps. That is what average path length describes about. It is a measure of the efficiency of the information. For example, if this is the shortest path, how we can send the information that if A needs dal, so he can immediately go to the 10-meter distance shop to get the dal. How much time it is taken? For example, if it take 10 minutes, for reaching 20-meter shop, it takes 20 minutes. So you will be sharing the information to the nose shop. 10-meter distance is quite faster than the shop which is 20 meters distance. So that is what it all speak about, measures of the efficiency of information. So this is the average path length. Let us now try to formulate it using and let us solve one more example. So formula for shortest path length is average path length is, formula is given by, so length of graph is equal to 1 by n of n minus 1 summation of, where I not equal to j of distance of vertices vi as well as the vertices of vj. Why we need to take the sum? We have to take the sum to find the shortest path, right? So we'll be taking the shortest path between the two vertices. And what is n? N is nothing but the number of nodes it is. Number of nodes have. So where n is equal to number of nodes, and d of vi and vj is nothing but the shortest path between two nodes. So the shortest path between two nodes. Let us try to solve using one example. So it is a node 1, so node 3, so node 4, node 2. So this is a graph given. So they are told to find the average path length. How we should do? We should find the number of nodes. What is the number of nodes here? So number of nodes is 4. So we got the denominator, but we need to add the sum of the vertices of sum of the distance between two vertices. So let us try to calculate it. So d of, so let us start from 1. So 1 to 2, 1 to 3, 1 to 4. What's the distance? So 1 comma 2. So for 1 to 2 it is 1. For 1 to 3 it is 1 distance. For 1 to 4, so for 1 to 4 how much we need to travel? 2 distance we need to travel. Next coming to, so 1 is completed. From 2 we have to take 2 to 1. So 2 to 1 we will be requiring only one step. So for 2 to 3 we will be requiring only one step. For 2 to 4 we will be requiring 1 to 2 steps. So 2 completed. Now let us take 3. For 3 to 1 we will be requiring only one step. For 3 to 2 we will be requiring one step. For 3 to 4 we will be requiring only one step, 3 to 4. So now let us take 4. So for 4 to 1 we will be requiring only 2 steps. For 4 to 2 we required 1 to 2. So for 4 to 3 we required only 1. So we have found all the distances. That is nothing but the shortest paths between the each and every vertex. Now let us try to put all these values in the formula. So LG, that is length of graph, is equal to 1 by n of n minus 1 sigma, where I not equal to j. So did you see that there is no condition that I equal to j? That is what here it is. Distance of vertices of I minus vertices of I as well as vertices of j. So 1 by, what is n? N is here 4. 4 of 3 of, we have to sum all the values. So 1 plus 1 plus 2 plus 1 plus 1 plus 2 plus 1 plus 1 plus 1 plus 2 plus 2 plus 1. So this is what the this is how we should calculate the average path length. So let us calculate it. 1 plus 1 2 4 5 6 7 8 9 10 11. So it is 1 11 12 13 14 15 16. So we got 16. So 16 by 4 3s are 12, which results to 16 12 1s are 12, right? 1.33. So shortest path, that is the average path length LG is equal to 1.33 between any two vertices. This is how we will be finding the average length path. I think your concept is clear. In case if you want any, you can do it for more than 2, 3, 4 graphs. So let us. So this is for today. So what we have revised, just we will be recapping what we have learned now. So we have seen the properties of real world network. Later we will be moving to the random graph model. So for in properties of real world network, we have seen the properties. We have seen the power law distribution, cluster coefficients, as well as the shortest path length. For power law distribution, power law degree distribution is nothing but the fractional relationship between two quantities, where one quantity varies as the power of the other. For example, you can take the volume of cube or volume of cubit or volume of rectangle, anything. So it depends, one depends on the other for this value to be raised. That is how we will be dividing. For example, if you have a sweet with you, you will be sharing the sweet with a fellow Europeans. That is how you are spreading your sweet to all your friends. So what is cluster coefficient? Cluster coefficient is nothing but we will be dealing with the degree of a node. That is what cluster coefficient deals with. So why we need cluster coefficient? We need cluster coefficient because we need to bring the strength of the network. We need for effective passing bandwidth. It is high. It has high security also. So we have given a formula 2NB by kV of kV minus 1. So I think we have all recapped this. So let us move to the average path length. Average path length is nothing but the average number of steps required to reach the two vertices or the one vertex. That is what average path length it is. It is a measure of efficiency of the information. So there later we have tried to formulate it using this formula. LG, that is length of graph, is equal to 1 by n minus of n minus 1 sigma, where I not equal to say for distance of two vertices. So we have taken one example and we have tried to solve that example. So that is for the topic 1, that is properties of real world network. So later we will be moving to the random graph. Thank you.